Thanks so much, Ben. Really appreciate the intro and the chance to be here. My talk today is titled Dear Shiny, It's Time to Break Up, which is actually a little bit of a misnomer. We're not going to be talking about breaking up with Shiny, but like breaking up Shiny apps. If you want to, you can tweet at me at AlexKGold, and all of the code and slides I'm going to be sharing today are available at the GitHub link at the bottom of the page here. I also do want to say that this talk is pretty much addressing people who are using Shiny already. If you're not, here are hopefully some exciting things to take on down the road, but this isn't necessarily a talk directed at folks who aren't already using Shiny, at least to some capacity. So just a couple quick things about me. I am a solutions engineer at RStudio. That's my puppy. We've only had her for 2 weeks. She's very, very cute. I figured that was more interesting than a picture of me, so there's my puppy. So what it means that I'm a solution engineer at RStudio is that I talk a lot about stuff in production, which like nobody actually knows what that means. People mean a lot of different things. Maybe they mean it's something that's deployed or whatever. But today I'm going to sort of take a twist on that. And in particular, I'm going to talk about code quality and in particular, as you could guess, code quality in Shiny. How do you write good Shiny code? Particularly when your apps get big and complicated. How do you make that work? So the thing about Shiny code quality is that it's hard. It's hard to write good Shiny code. There's nothing in Shiny, which is an amazing framework for interactive apps in R. There's nothing that enforces you to write good code, right? Your code structure can be crazy, and anybody who's written a big Shiny app before, I'm sure, has had this experience where you just end up with, despite your best efforts, you have like total spaghetti code. You have like some UI elements here, you have some server elements here, you get your data here, you do some processing here, and it becomes a mess very, very quickly. So I want to talk today about 4 patterns to break up big apps that I've used before and found really productive for making sort of big apps, making the code for big apps more tractable and easier to work with. So here are 4 patterns to break up big apps. So pattern 1 is to take your business logic and put it into a Plumber API. So very often a Shiny app will sort of mix up what you would think of as sort of your vanilla R code, right? Like the real content, what you're doing, the meat, and it mixes that all up with the Shiny UI stuff. Like how does the user interaction work, right? That sort of gets all mixed up in Shiny. And so the first thing you can do to clarify your apps is just take all of that like business logic stuff and pull it out and serve it out of a Plumber API. So you can sort of completely segregate that from your app code. That's step 1. And I should say these steps are sort of like escalating in terms of like how, they should follow one after another. I would say, you do what you want, but in my experience, this is sort of the order. If doing one makes your app simple enough, great, stop there. And I'll talk a little bit about how you would choose to go from one to the other. Step 2, write a package. This is like always the advice in R. But putting your app code into a package makes it way more maintainable. It forces you to document it and makes it easier to sort of have it, again, separated from the actual Shiny code itself, which can be really useful. Step 3, and so this is where things start getting heavy duty. Steps 1 and 2, I would recommend for almost any Shiny app that's greater than like, I don't know, 150 or 200 lines of code. Probably worth it to do 1 and 2. Step 3 is where like this is for like big Shiny apps that really get pretty sprawling, and that is to use Shiny modules. If you've never used Shiny modules before, they're similar to functions in regular R. So you can think of the analogy of like R code to an R function is a similar analogy to like a Shiny server module, a Shiny server to a Shiny module. A Shiny module allows you to clearly specify a chunk of server logic and separate it out from the rest of your app. So that can be really useful. The cost is that there is some complexity in using Shiny modules in terms of managing namespaces and things like that. And so this fourth, number 4 is to write an R6 class to wrap around what your app is actually doing. This is particularly useful if you're wrapping around an API, which if you did step 1, you are. I have to have a big caveat on step 4, which is that I've talked about this with folks at RStudio who actually like write these packages like Shiny and R6, and they were like kind of skeptical about this. So like big caveat that maybe I'm like way off the ranch here, but I found it super useful. I recommend it personally, but this is definitely not like an RStudio recommendation because the people who would make such recommendations aren't so sure about this. So take that for what it's worth. So just to be clear about sort of the trade-off we're making here, though. So what you're doing if you follow these steps is you're trading complexity for clarity. You are lowering complexity, increasing, but also, sorry, I should say this the right way. You are decreasing complexity of individual pieces, increasing complexity of the sort of system as a whole, but also increasing clarity. And so what I mean by that, and I will actually make it clear this time I say it instead of a mess, is that you have more pieces, right? You're adding pieces to your code. You're adding a package, you're adding an R6 class, you're adding pieces. But you're also getting more clarity, right? Each piece is getting clearer in terms of what it does, and that can really be worth the trade-off depending on, right, how much you're trading off here. So now I'm gonna go to a demo app that I have here that I think will make this all like clearer and easier to understand. So we're going to stop the presentation and go here to the Shiny app that I have. Oops, where did we go? Hopefully I'm still sharing the right screen. I hope this is that you all are seeing my RStudio session and not my Twitter feed. So hopefully, sorry, Gwen?
I'm not seeing it.
Okay, well, let me unshare and reshare then.
You still see your browser.
Got it, cool. I will, oh, I see, resume share. How about now? Do you see the RStudio ID?
Good to go.
Great, excellent, thank you. Okay, so here's the app that I'm gonna be working with today. And what we're gonna do is we're gonna take this exact same app and we're just gonna mess with the code over the next 10 or 12 minutes. If any of you saw my talk at RStudio Conf about capital bike share bikes, this will look very similar. I cribbed a lot of the code from that because I am lazy. So that's why this might look familiar to you. As most of you probably know, we have our awesome capital bike share system here in DC of docked bikes. So you can go to a dock, rent a bike, ride around, and then dock the bike again. It's awesome. And so this app, and what's even cooler is that the capital bike share system makes real-time data about bike availability available via their API, and you can just use it however you want. It's very cool. It's fun data to play with. So that's what I'm doing here is what I'm in real time. When this app started up, it sucked down the latest data from the API, and you can see at Wisconsin and O, there are 9 bikes and 10 empty docks. At 17th and K, there are 11 bikes and 24 empty docks. So this is a pretty simple app, right? This is a leaflet map. This is a Shiny dashboard. And the only interactivity I have other than being able to click on the pop-ups here is that I can refresh the map, right? I can refresh the map and it updates the update time, and it also updates the data here, although it's gross today. I doubt anybody's really biking around, so whatever. So that's the app that we're gonna play with here. And I just want to go over the code here a little bit because we're gonna be like messing with this code. So let's talk about this code for a second. So again, it's a pretty simple Shiny dashboard. If you used a Shiny dashboard before, I've got my top box with that leaflet output in it, that map. I have my refresh button, and I have my last updated piece. And so those are the only UI elements, right? There were those 3 pieces. And then in my server, I have sort of this long section that gathers all the data. And to just be clear about how the data gathering works here, the capital bike share at this location makes available a list of feeds. So like each feed is like, here, I can actually just run this. And so you can see like each feed is like the system alerts, and then it gives like a URL, right? So that's how I get the actual feeds. Then I'm gonna get the URL for the feed, and then I'm gonna actually get the data from the feed. So here I have sort of 3 pieces. I have to get the feeds, I have to get the list of stations, right? Because that data is actually separated. So they have the stations, which is like the name and the lat long, which I'm using to put it on the map. And then I'm getting the actual status data, right? The actual real-time status data, which includes the time update, and also the actual like returned data. Yeah.
We are only seeing the RStudio console right now. If we're supposed to also see the app as well.
Oh, that's fine. Yeah, you should be just seeing the code.
Fantastic.
Are you seeing code or just the console? Okay, great. Yeah, yeah, I guess I could pull up the data, but or pull up the app here. So just to clarify what I was talking about, right? Where did the app go? Here we are. So right, this box here with the leaflet in it corresponds to the box around the map. This button is the refresh button, and this text output is the last updated box at the bottom. And then that was all the sort of data gathering pieces. Still just seeing the app, or still just seeing the code?
So the code on the left, I see it. Everything on the right, I do not see. So
Okay. Okay. Cool. We'll move on. I'll come back to it, so that'll hopefully help. But thank you for letting me know. I will make sure to share it correctly the next time. Cool. So just to sort of recap, right? We have 3 UI elements. We have the map, the refresh button, and the last updated output. We have this like data gathering section, which has 3 parts where we get the feeds, the station sort of metadata, and the actual data on the statuses. Then I have the section where I'm like actually creating the plot data, a section, and then I'm actually creating my outputs down here at the bottom. Pretty straightforward. It's not a huge app. And so what I should say first off is that like in real life, I probably wouldn't do any of the things I'm about to share to this app because it's fine. It's simple enough as it is. But I wanted to share an app that sort of people that would be understandable in the scope of this talk, and that I could show off doing these things too. So first caveat, right? I wouldn't actually use to this app. This app is fine, but apps get bigger, and then the steps I'm about to show are maybe more important. So going back, the first step is to add a Plumber API and separate out my app into sort of 2 pieces, right? I have a Plumber API that now lives separately from the app itself. And so I'm going to do that. And what that's going to look like is I'm taking here like this, the feeds component here, right? And that's becoming an endpoint. That's my feeds endpoint on my API. And I can also get the feed data. So actually, let me show this. Where did I put this? There we go. Here's that API. And so on this API, you see if I hit feeds, there's no, I could supply a language, but I'm going to do it in English because I only speak English. So here I get all the feeds. And then if I take a feed URL and give it to the feed dat endpoint, it gives me the actual data from the feed. In this case, there is none because there are no system alerts. Cool. So now I have this separated out into my Plumber API, and I have to re-architect my app a little bit around the Plumber API. In this case, I actually get like I gain almost nothing by doing that, and the reason is because I'm doing so little to this data, right? Like I'm reading in this data from the API. This is the only actual data cleaning I'm doing. I'm extracting like these 2 lines are data cleaning, and like this line is data cleaning. So there's almost no actual business logic in this app, which is why doing this doesn't help me a ton. But in bigger apps where you have a lot of business logic, pulling out that business logic can really, really simplify what the app looks like. So if I go down here, right, the slight differences are now I have like this API, which is the deployed location of my API. I should say I'm deploying the API here onto RStudio Connect because I have one handy. You can deploy this to RStudio Connect. Obviously, you also can use, there are lots of open source options to deploy Plumber APIs that are very available, and you can check out the Plumber documentation if you're interested to learn more about them. Now what I'm doing is instead of making that call directly to the bike API, I'm making the call to my API, to my feeds. I'm getting it, and then I have to do a little bit of work to get it into like a Tibble format from just like an HTTR response, which is this weird object. And then I'm doing similar things in terms of pulling down the actual information, and the rest of the data sort of looks similar, right? I'm pulling down that data from the API. I'm providing a query here because I'm giving which status URL I want, and then I'm getting the content, getting the last updated time, and the data there. So that's what adding a Plumber API looks like. So we've added a Plumber API. Now let's wrap some of this work into an R package. So for those of you who haven't worked with R packages before, I highly recommend doing them for all of your projects in R, including Shiny apps. So here's what this is going to look like. Is now I'm going to take that get feeds list function, which before was sort of this chunk here, right? I'm just going to make this a 1-line function. Great. That was easy. Just extract that data. I'm gonna do the same thing here to do the get feed URL. Right now, I take a parameter here as opposed to sort of supplying it down here, and I'm able to extract that into a function. Similarly, getting the actual feed data, I'm doing that, and making the plot data down towards the bottom, I'm extracting all of that into functions. And so now this app now is going to look a lot simpler, right? Now, what was, how many lines of data gathering code? So here I had from 33 to 81 was data gathering code. So that's what, 48 lines of data gathering code. Now I've got 9 lines of data gathering code because this is like, extracted into a function. Again, lines of code is not necessarily a measure of code complexity and code quality, but in this case, I think it's a pretty good proxy. So, take that however you want to. Similarly with the plot data, right? I've extracted what was like 10 lines of code and it's 1 line now. And so what this is starting to do is make this Shiny app much more declarative in terms of what I'm doing, right? Instead of having to parse a bunch of HTTR code, if I'm looking at this and trying to maintain it, I see like, oh, I'm getting the feed data. I can go and fix that function if it's broken or if it needs updating. I'm not saying anything new here, right? This is why you use R functions. But the entire idea here is to make the Shiny app more expressive of what's going on and make the individual chunks smaller and easier to sort of grok when you're going back to it later. Okay, adding Shiny modules. I'm gonna jump through this part pretty quickly because modules are hard. And so I'm not gonna go into the detail here of like how the module works and that sort of stuff. What I'm gonna say is I extract it into a module. And what a module allows me to do is it allows me to have a particular piece of UI. In this case, I'm taking the refresh button. And it allows me to take some server code. In this case, I'm taking sort of all the data gathering code, put those together, and then in my app, which I'm now losing off the end of the screen here, I'm going to close down some of these older ones. In my actual app here, this actually won't look so different, except now instead of that function call, I have the call module here. And now the package call is inside the module, right? My get feed dat. And so, this again, in this app, probably definitely more trouble than it's worth to use modules here. But what this allows me to do now is it allows me to segregate out not just some functions, but actual reactive behavior, right? I can now put the refresh button, which is the only piece of my app that actually interacts with the data, and the data piece together somewhere else, which allows me to simplify greatly. And then last up, I'm going to add my R6 package. And so if you haven't worked with R6 before, R6 is an R package that allows you to write more expressive classes than maybe are available using standard S3 in R. It can be really cool for making wrappers around, for example, APIs, because you have something that looks like an object dot method in Python. If you're sort of used to that, this is going to look like that, except it's going to be a $sign because it's R. The downside is you write R code that doesn't look that much like R code. So definitely be careful here. And again, big caveat that the folks who are really experts on this were not so sure about this idea. I found it very useful. So again, so like this is what this looks like. Now I've created this API client. And so now I just get from the API client my status, my last updated, that kind of thing. And it can make the app much conceptually simpler to work with. So just to like give you a sense of how much simpler I made this to work with, I did a little analysis of the number of lines. Again, number of lines, not a great proxy, but I think, or not a great measure of code complexity. In this case, I think a reasonably good measure. So what you see is, as I went across the examples here, the total number of lines of code went up, from 125 to like 160-ish, right? So that was a meaningful increase in the total number of lines of code. But what dropped drastically is the number of lines per file. So this blue line is the mean number of lines per file. And so in the R6 version here, I have like 46 lines average per file, which means that each file is easier to understand. And this, right, as I said, sort of this drop might be even more significant if there was more to extract from that original app. The original app being so simple left me like relatively little to do anything with. So let me go back to the end of my presentation here. Okay, just so you know, I'm not like BSing here. I do want to show you this. This is an app we use at RStudio to manage workshop infrastructure. So like at RStudio Conf, we had to launch 500 EC2 instances to be able to run our interactive workshops. And this is a Shiny app that does that. So we have like our classrooms up here. We can edit attributes of the classrooms, like, what GitHub repo are they pulling here? And we can actually launch EC2 instances from the part of the app down here. And this app is built using these 4 ways of breaking up code. And I don't think we would have been able to make this app as good as it is and as stable as it is without doing that. So highly recommend this pattern for complicated, big, Shiny apps that are interacting with external services. Takeaways, I have my 4 patterns here. So put the business logic in a Plumber API, write a package, use Shiny modules, write an R6 class. Thank you for your attention. Again, please tweet at me at Alex Kagold if you have questions or anything. I also really want to give credit to these ideas, to my colleague, Cole Arendt. I've done a lot of work with these ideas, but a lot of this sort of came originally from him. So big thanks to him for working with me on a lot of this. Again, the code is at GitHub, AK Gold, Shiny, Breakup, Saturday. And thanks for the slides template from Slides Carnival. Oh, one other thing that I want to mention. A lot of people like the Golem package for doing this, which puts your Shiny app into an R package. I hear it's great. I've just never used it. That's why I'm not talking about it. The other thing I want to mention is if you think it's cool that I have these R package hex stickers all over this presentation, I have an R package that is called StickR. And so if you think that's cool, why is this not working? I think I have this. Maybe it's not installed here. That's sad. Anyway, it's a cool package that I wrote. It lets you just get our package stickers with the sticker get command. And if you're interested, please do check it out. I would love feedback, and maybe I'll put it on CRAN eventually if people are using it. So the StickR package. It currently doesn't have a hex sticker, which is a little ironic, but maybe I'll fix that at some point if people are using it. Anyway, thanks for your time.
Thank you so much, Alex. Just a quick question about the sticker package. How do we contribute our own stickers to that?
Yeah, so that is a great question. And there is not a great, I don't think I have this super clearly documented on the repo. Generally, stickers are put in a couple specific places in a GitHub repo for your package. And so if your sticker is in that place for the Git repo, it will automatically get it. Let's see. It's somewhere in here. I should probably add that to my documentation, and I will do so maybe tomorrow, Ben. Thanks for the question.
Fantastic. Thank you so much.